study transform of second order filters. A general expression of difference equation of second order IIR filter is like here. So the order is n is 2. To get G transform of YG, we can take G transform on both sides. Since G transform has a linearity property, so we can transform each term. For here will be A1 G minus 1 YG. Here A2 A2 G minus 2 YG, like this. So after getting each G transform with each terms, we send this YG related terms to left of equation, and we factorized and divide by these terms to get the ratio of YG to XG. The example is here. So 0 will be happen 0 and minus 1, and this is 2 over B is 1 plus minus 4. So it will be 1 plus minus J equal to 3. So here is 1 and here's half. This is 3 and this is minus equal 3 over 2. So we have 2 poles and 2 zeros. So the impulse response is inverse G transform of system function. To get inverse function, we should consider the fraction. It is improper fraction or proper fraction. To check it is improper or proper fractions, you should check the order of numerator and denominator. So here is the 2 and 2, so it is improper. So here consider this improper. We should, it is 1 plus 0.5 G minus 1 minus 0.8 G minus 1, like this. Minus 2.1 G minus 1 plus 1. So here is proper fraction. So we can use partial fraction expansion like this. So we can divide into factorize the 2 factor, and we can expand using partial fraction expansion like that. So using this equation, you can get AK. So after that, we can take inverse G transform. Okay. So let's do be 1 plus 1 plus 0.5 minus g, 2 minus 1 minus 0.8 minus g, 1. Actually, this is 1 minus 0.5 minus g. So G transform, inverse G transform, 1 will be delta n plus 2 minus 0.5 and un minus 0.8 and un. You can solve example. Here there's 2 and here is proper fraction, so you can use partially fractional expansion like this. So you can get a and b here. So finally you can get hg like this. So after inverse G transform, so we have this one. This is 2 exponential exponential 3 j pi n plus 3 pi. Remove this and j. And this is 2 exponential j 3 pi n minus pi over 3. From Euler relationship, we can get this one. So the frequency response can be obtained from system functions by plugging in exponent j omega hat at z. So similarly, we can get magnitude squared here, and the pole will be 0.9 exponential plus minus j pi over 3, and zeros will be plus minus 1 like this. So in the G domain, pole zeros will be here, pole will be like this of here. So where it becomes maximum value, actually closed here will be maximum value here or this, because it very close to pole. So when you put omega is pi over 3, it will be 10.522, but actual maximum value will be 10.557 at 0.334 pi. Is very close. So our guess close to pole here, it will be similar like this. Okay. So when you draw the magnitude of this, so close to pi over 3, you will be maximum value. like this. If this it is band pass filters, but how much is the bandwidth? So we should define where is the cutoff frequency. So definition is H peak square is the power or half power, means that square root 2 H peak. So we have 1 over square root 2 times H peak frequency called cutoff frequency, and the bandwidth between them is called 3 dB bandwidth. So here 10.5 divided by square root 2 will be here. So we call this is 3 dB band, 3 dB bandwidth. Okay, approximately it is 0.707 H peak. Around 70% of peak, the maximum value will be the cutoff frequency we consider. Using MATLAB, you can get the frequency response here, and the value will be from this, and the feedback coefficient is 1 minus 0.9 and 0.81. We already studied, and here feed forward the value is 1, 0, minus 1. This using filters we can get like this. So we're gonna take absolute value of frequency in the domain. That after plotting we can get this one. So using MATLAB we can get magnitude and frequency response. So in the case of IIR filter, it's easy to draw and understand, but due to non-linearity of IIR filter, so it is difficult to handle written. So we're gonna use MATLAB like this with functions. And here is another example of IIR low pass filter. So here pole is close to lower angle like this. So here will be a certain value and comes to here, and here will be smaller value like this. So we call it low pass filter.